Alright, hey everyone, thanks for stopping back to OMC Built. This is going to be episode 2 of my first 4x4 build. It's probably going to just be 2 parts, little shorter episodes. The fabrication is not nearly as intense as what we did for the pre-runner style front bumper. In this episode 2, we are going to be making what I would call some rock crawler side steps. I guess they wouldn't be steps, they're not really going to be made for stepping on necessarily, just something to kind of tie in the look of what we have going on here. I'm really not going to be doing a lot of rock crawling with this thing, honestly. In Minnesota, I don't know that there's that much of it unless you probably head up north to the North Shore and stuff, and hopefully I'll get up there and make a video, but it's definitely not going to be a rock crawler by any means, and honestly it's not going to see that much dirt in its life. It's really just a daily driver that will take on any conditions that are presented to it. But today we are going to be making some side steps. Like I said, we're going to take some 1.5" tubing and throw a couple bends in it, weld it together, make a dimpled plate for it, and mount it to the frame rail. It'll be real simple. I've gone ahead and taken the little shorter part of the fender off here that was kind of like a mud flap. I was gonna just trim it flush with the bottom of the rocker panel here, but I didn't think it would look right, so that had to go. I plan on masking this off and spray painting this black before the sides get permanently welded on, so that it just kind of that little bit of red won't stick out like a sore thumb. And then on the rear fender flare here, I went and cut it. Used to come all the way down, and that was going to be in the way of the sides, and I didn't want to have the sides, I didn't want to cut the that bit of it super precisely around there. I wanted this to kind of match the front a little more, although the front is higher. I was considering chopping this up a little bit more, but I think that's a pretty good look right there. And so basically all we're going to have is we're going to have a straight piece of tube that goes the whole length of the rocker, and then it's going to have another tube that comes up off of it, bends at 45, bends back at 45, and then there'll be a plate with dimples between that, and then that will come and mount to the frame rail here. Just put some plates on it, and then some little tubes that stand off and meet up with our unbent tube there. So it should all be pretty simple. I think we'll do gloss black on it. That's what we did on the front bumper, so have it all matched like that, and that way it won't be hard to get to some parts of the tubing. The front bumper, when I painted it, it was a little bit of a pain to try to coat all the tubes 360 degrees, and in fact there's a few tubes that don't have paint on it, so if it becomes a problem and starts to rust, I am going to have to deal with that, and I'll probably deal with that over the winter when I am going to service a lot of the engine, fix some of the leaks, do all that stuff. So first we're going to come over here to the steel rack, and we're going to be using some 1.5" DOM tube I have left over from when I used to do a bunch of roll cages. This type of stuff you could easily get away with using ERW tubing. It's probably about half price per foot. ERW is electric resistance welded, so it has a seam all the way down it. For roll cages, you never want to use that. That's the weak part of the tube, especially when you start bending it. That seam can come apart. DOM tube actually starts off as an ERW tube, but there's a secondary process where they roll it over a mandrel to basically get rid of the seam. So DOM is sometimes referred to as seamless tubing. Not getting fancy with chromoly or anything like that. Just using some 1.5" by, that's probably close to 1/8" wall thickness tubing. I got plenty of it left to build some sides, and then we're going to use a combination of some 1 3/4, 1 5/8, and 1.5 inches to do a rear bumper, and that will be featured in episode 3 of my first 4x4 build, which will be coming a couple months from now probably. The rear bumper is not going to be as much of a priority. I haven't even turned this into my daily driver yet. I've, put maybe 40 miles on the thing, and I've put no miles on it since I put the rims and tires on it. So really just want to get the side steps done, welded on, painted, and I need to get a front end alignment, and then this thing will become my daily driver. So I'm going to first take a measurement here for the length of the tube that's going to be underneath the rocker, and I will cut 2 of them to length. They will be capped on both ends, but we're not going to worry about that till later. With a tube that long, it's usually not that big of a deal, but if there's a smaller length of tube and you sealed the ends, anything that you welded to it, you'd be heating up that volume of air, and if you have good penetration, you can have a blowout where that air that has expanded inside the tube is trying to escape. So we'll leave the ends open while we do the fabrication. Capping the ends will be one of the last things we do before we paint it. And so I will get down some tubing, cut those 2, and once I have that done, then we will figure out the outer part of the tube that will have the 2 bends in it, and we will break out the bender, get those done. Then we break out the notcher, throw a couple notches in them, and from there we'll make a dimpled plate. So see you in a bit. Alright, I got my 2 pieces cut. Ended up being 66 inches, and I found a piece of scrap that I had laying around. It's bigger, but it just for visualization, this is kind of what I'm going for. This pipe, or this tube, is going to be wider, but I just kind of wanted to visualize the distance between the 2 and see what type of bend I want to go with and everything like that. So this piece of scrap worked out perfectly just to kind of get an idea. I generally like how far away the 2 tubes are. I think that's a good distance, but I want to get it mocked up down under the vehicle so I can kind of get a good visual. The proportions might be off once I get it down there. And like I was saying before, there's DOM tube and ERW. This is ERW. You can see it still has the that's the weld mark right there, the discolored part. And then if you look on the inside of the tube, might be able to see it kind of where, but that's the seam right there. You can actually feel it and see it. So this tube, if they took this tube and then normalized it with the mandrels, it would become DOM tubing. DOM is drawn over mandrel. So they take ERW, they draw it over a mandrel, it becomes DOM. That normalizes it. What that means is DOM, besides having no seam in it, also the wall thickness is much more precise than ERW. ERW, it varies a lot more once you draw it over those mandrels. Like I said, it normalizes everything and creates a much better tube for structural applications. Like I said before though, ERW I think would have been just fine for this application, but I'm going with what I have. No sense in buying new tubes. And so let me grab some jack stands and we'll get the 66-inch tube up underneath there where I think it's going to go, and then we'll hold up that piece of ERW and see if the distance is going to work and kind of plan from there. So I'll set you up here. See if this is going to stick out too far, if it's going to be good. That's going to come up at an angle like this. You got to make sure that you can still open the door, of course. but generally it's gonna be something like this to be able to protect the sides. So I really do like this, so we can use this just to get an idea of how we want to make the actual tube. It says it's going to be wider than this, but as far as the distance between the two, I like how that worked out, so you can just use it as a very rough template. So now what I'm going to do is cut. Well, this pipe was 114 inches, this tube, not a pipe, I keep calling it that. This tube was 114 inches before I chopped it, so it worked out perfectly to do, wait, no. It was, let's see, what, 130, it was about 136 inches, I think. Either way, I got two 66-inch pieces out of it with about 2 inches left over. So I'm going to take another piece of that tubing and I'm just going to cut it right in half, and then we will throw bends in it, throw notches in it, make any adjustments, and then it'll be time for some plate. And I got some 16 gauge cold rolled steel for that. So this should move along pretty fast. So I'm gonna grab another piece of tube, gonna chop it in half. I'll break out the bender, so I'll see you in a little bit. Alright, I got the next section of tubing cut in half. I got my Mittler Brothers tubing bender set out on the table. If you want more information about the bender, go check out episode 1, part 1 of the pre-runner style front bumper build. I get really in depth about the features and the limitations of it and provide some tips and tricks that I've learned along the way with the machine. We are going to bend up the section of the rock crawler style sides that is going to be the bent part here. And so, as I discussed in my previous videos with this bender, one limitation of this bender is with the follow block, and most tubing benders have this limitation in some form. With the follow block, you have to have a certain length of leg to use as leverage to make the bend. And if you watch those videos, I usually bend from the inside out. I like to find the distance I want between the bends and then bend from the inside out. On this one, we're going to be bending from the inside, or from the outside in, because there's just not enough leg left to use as leverage. So I'm going to just grab the pipe. It's a tube. I'm going to grab the tube in the same spot and create two bends, and I'm just going to kind of freestyle it first to see what angle I like. That piece of ERW I was using just to get a visual was right about 35 degrees. So I grabbed my bend protractor, set it to 35 degrees. So we're just going to roll two bends into each side, into each end of the tube at 35 degrees. And then we're going to take it out of the machine, hold it up to the straight piece that we've already cut, get an idea of how much, the notch is going to take out of it, and we might end up going closer to 45 degrees with it. I'm not really sure, but let's load up the tube into the bender here. So I'm just going to get the tube flush here with the end of the die, and then we'll clamp it in place. That'll be real easy to get both sides equal, and if we want to add more bend into the tube, it'll be really easy to figure out where the tube was the first time. We'll also be marking the die as well, as you saw in my previous videos if you've watched them. So now I got the saddle clamp tight, this is flush. I'm going to take the slack out of the machine. There we are, slack is gone. So we'll hold up our bend protractor here, 35 degrees. It's going to be a little hard to tell because there's just this little bit of stub sticking out, but as long as we get both bends equal, that's all we really need, and we can do that by just measuring like we did in the other video off of this surface to this surface, and that way our bends will come out equal. So let's start bending. Now, since it's kind of hard to get a visual, since like I said, if there was more of a leg sticking out, it'd be a lot easier to find the angle we're at. But what I can do is get the bend protractor here parallel with the follow block, and then I can use a square off of the saddle to check where we're at, and that is actually very close, maybe one or two little chugs, and we'll get it there. So I'm going to take a measurement here and see, and I usually like to break it down by 16ths. It's just easier than breaking it down by 30 seconds, and we're in between 16ths here, so I'm just going to chug it a few more since we are shy of that 35 degrees. Alright, so now you can see that we are just at 1 3/4. So we will be able to make an accurate bend on the other side. We'll just bend it till that same distance occurs at 1 3/4. But what I'm going to do, since we're just kind of freestyling it, is I'm going to mark the tube right here on the clamp. This is a 35-degree bend. It's going to spring back probably to about 32, but it is still shallow enough that there could be a little bit of twist in it that you'd be able to introduce and still clamp it. It's not going to go back in only one place, like if it was, you know, steeper than 55 degrees or something. So I mark this so that I can line it right back up. We get it flush up here, and then we line this up so that we know we got our twist right. And then if we need to roll more bend in it, we can do that without creating a twist in the bend or a double bend. If you were to grab the tube, you know, if it was a 1/4 inch recessed or a 1/4 inch further out, it would seem like it will fit back in the die just fine. But once you start rolling it, you'll actually have a flat spot in your tube. So we are going to mark down on our little sheet over here that we are at 1 3/4 for that bend. And now we will loosen up the machine and flip the tube around. And I can already see that I don't think that is going to be steep enough for what I want, because I want the distance between these to be, I don't know, maybe about 5 inches, and right now it's probably about 4 or less. But we're just going to go ahead and roll the other side, and we'll add more to this and then go back and even it out. So this next bend is the real important one. We're going to get the clamp tight, or at least snug. We want to get the snout here, the end of the tube flush with the end of the die. I'm going to take some of the slack out of the machine. Now what we got to do is get our twist right. So we want both of these bends to be on the same plane. We don't want there to be any twist between them. A little bit might be imperceptible, but so all I'm going to do is I'm going to look down the distance here, and you can use the follow block and the die, and if I move this hose out of the way, at least get it out of the line of sight, you can see now what I can do is I can look down the tube, get level with by using the follow block there and the die, and then I can look at this end right here, and it might be kind of hard to tell, but if you do it on this side, you kind of follow this curve back to the follow block and you get that level, and then you look down the center line of the machine, you can tell that it's running uphill. So I am going to give this a twist down. That was too much, we'll twist it back up. That's looking pretty good, but we want to get it better than pretty good. We want to get the thing as dead nuts as we can. It's a technical term. Dead nuts. Cool. That looks good to me. So now come over here, make sure that we're still flush, give the clamp another tighten, and we are going to start rolling the bend out to 1 3/4 inches, and then we are going to add some more. So let's set our bend protractor, let's see, 40, let's set it at 45 just for a visual. We might not go that steep. And let's start rolling. Alright, that's 1 3/4. So now we're gonna roll it out just that little bit more. Alright, we're getting close to our 45 degrees on the protractor. It's going to spring back probably about 4 degrees, but we're just using this as a rough guide here. Alright, now let's take a measurement here. And we're between 16ths, so I'll just go that little bit more, making sure I get my fingers out of the way of the machine. We currently have 10 fingers. I'd like to keep it that way. So that is 2 3/16. So we're going to cross this out. We'll go 2 3/16. Now we're going to mark the die as we always do. And now I am going to release the tension. We'll flip the tube back around. We'll rebend that to 2 3/16, and then we'll have a lookie and see if that's what we want to end up with. Yeah, just looking visually at that bend we just did, it looks quite a bit better. So now you can see the mark I made here is going to line up with the die. We're going to get it flush, put the clamp on, and get it pretty flush, clamp on, and then I'm going to take this follow block and push it forward so the tube's in it, and I can see that the twist is pretty good, but as it often does, the tube being pulled slid backwards just a little bit back from being flush on that. But if I get it lined up, then we're good. So you can see that the mark I made before is lined up. So we'll give this a tighten here. Alright, so we got this tube bent to 2 3/16 now. I'm just going to push the bender out of the way for a second here. And I'm going to grab the tube that we cut that we're not going to bend. We'll give it a look here. So this is the distance that we have between them right now. But the notch, if you go perpendicular to this tube, this distance right here, if you take the shyest notch you can, that's going to be the distance that the tube gets closer to it. So I want the tube to be about where it is where I want the tube to wind up. So we're going to need to throw steeper bends into this still. So we will get it back in the machine, and I'm going to set the bend protractor to so we bent that to 45, and the actual was 43. So it didn't spring that back that much, but I think we're going to want to go to closer to 60 even to get the distance that we're looking for. I'm going to split the difference. We're going to go to 57.5. That way it should spring back to about 55. So let's get the bender back over here. Get the tube back in where it needs to go. It's about right. It's pretty close. We're gonna give it just a little adjustment. I think that is exactly where we want it. And we'll roll some more bend into it. I just set the bend protractor back to 55, 57.5. Might have been a little aggressive. So we're gonna give her a check. It's close enough there. So now I'm gonna take another measurement and we'll get it to the next closest 16th, which it is actually right on a 16th. So that looks like it is 2 9/16, just past 2.5 inches. 2 9/16. So now we will make note of that. Cross the old one out. Let's flip the tube over, get that one bent. Now this time I'm not gonna let the ram go all the way back. So it'll be a little bit easier. Since the tube's already bent, we don't need to zero the ram out. Let's get this guy pretty close. Just a bit further back there. All right, let's bend this one. Make sure we got everything in there. 2 9/16. 2.5. Now another way to do it, to get a visual, is just to put the tube on the table. Put the tube on the table, I can take a measurement. That's about 5 inches from the table, from the center of the tube, and that is a little less than an inch. So that would make 4 inches center to center for the tubes once it's notched. And I think that will be a good look for it. I don't want to get too wide and too bulky. So this tube's good to go, so I'm going to grab the other tube and we're just going to roll 2 more bends into that at 2 9/16 using the same techniques. Once we're done with that, then we can break out the tubing notcher and roll some notches in there. And we can weld the pieces together and make our plates for it. So this is just going to be as simple as clamping it flush with the end here. Little less. There we are. Alright, bend this to 2 9/16. Try to hit everything in the process, maybe break a few lights. All right, clumsy. Starting to think about food, I think. All right, there's that. Let's get some slop out of it and get this twist right. Loosen the clamp just a smidge. And it's running downhill. Get the cord out of the way. I like it. It's good right there. And we'll bend this to 2 9/16. There we are. We got the second part bent here, the second tube, and so we can put away the tubing bender now. That's the only tubes that are going to be bent. Everything else is just going to be straight. All right, I got the Bailey tube notcher out, set up, got an 1.5 inch hole saw on it because our tubing's 1.5 inch. If you want any information on this machine, any tips and tricks, watch episode 1, part 2. I go over a lot of the stuff here. So now I'm going to set up to make the notch in the tubes that we just bent. We just want the notch to be parallel with the long part of the tube there. So we will find that angle, then we will set it up in the machine. And I got one of my stands out that I made. Since the tube is so long, it'll put a lot of pressure on the clamp there, and when you, with the vibrations, when you are rolling through it with the hole saw, it's going to want to fall down. So I just got that out as a brace. So let me grab my T-bevel here, and we'll use that to set the angle. Now we're just going to simply use the T-bevel to find the angle here. Looks like just a little bit less steep. We're going to go with this. Now I'd like to grab a little piece of scrap. To use, I'll just chuck it up real quick, and then I'll use this to get the angle that we want. I'm dipshitting right now, but believe me though, I'll figure it out sooner or later. Well, I guess there's another way to potentially do it, is just to use the T-bevel on the side here and get it so that it is against this surface, because this surface is, I'm assuming, perpendicular to the clamp. So if we just do it here and we get that, that should be good. So that's about a 37.5 degree notch there. As long as we're a little shallower, we can always go steeper, but if we're too steep and we gotta go shallower, then we're gonna be messing with the distance, because what we want to do is just barely hit the inside of this and notch through it. We're not going to go into the tube because we want the distance that we already have. So we'll snug this down here, and we will throw a notch in this guy. The other thing is, if the clamp starts clamping on the bend, then we're going to have to adjust the angle. We're going to have to add in whatever the clamp is clamping on there. Looks like it is going to clamp a little bit, perhaps. Maybe not. Looks like we might just barely get away with it. Like I said, I just want to take the back half of the notch there, so I am going to use my Wixie digital angle gauge here. We'll put it on the surface here. We'll zero it. Then we can put it on our tube, and then we can get that thing done up. And it's zeroed. That, I just kind of eyeballed this up and set that. But hey, it is showing me that it is leveled to the machine. So that works out awesome. And I'm going to give this guy a clamp. It is clamping on the bend a little bit, but I don't think it is affecting how it comes out of the machine too much. We'll take my little square here and check it, and yeah, it is affecting the angle a couple of degrees. And this is I was about to notch it the complete wrong way. This tube should actually be flipped over on this side. That would have been a huge mistake there. See, sometimes you just gotta take a step back. This actually should be in this direction. So now I'll move this over here, and hopefully it can still pick up the end. It's really good when you just rail that thing with your shin. It feels amazing. At least it wakes you up. I think I'm starting to get hungry. Usually when I get hungry, I start making a few more mistakes like that. So, damn you. Yeah, let's see, this has to go back. I don't know if you can see it here. Alright, yeah, let's just do it that way. Alright, now I'm going to have to level it again. See how that's doing. So that's coming a little bit steeper. So this, we should add a little bit of angle to make up for the fact that it is clamping on the bend. So we are going to just go that extra little bit. And now we are going to re-level this. Zero that out. Put it on our tube here. And now it is going down by 1.5 degrees, so we will raise up the tube until we get 0. There's 0. So now we know the tube is parallel with the notcher, the shaft of the notcher, and we can tell that the notch is the notch we want because the unbent tube is going to go across this way, and that's the direction this is pointing. Like I said before, I almost made a pretty big error. It does need to go in just a little bit. Just a little. There we go. Now let's give this a snug, and it's ready for a notch. All right. 1 notch down, 3 to go. Everything's all set up now, so it should be real simple. All right, get that out of there. Tap that out. Now let's grab one of our pieces of straight tube and let's see how those notches did. And so here we are. Notches are exactly what we needed. Look at that. That's about as good as it gets. Now I'll hit this with the angle grinder, put a bevel in it, round these off a little bit, but that is exactly what I was going for. It's always good when things turn out how they did in your mind. So let's notch the other tube. Alright, we're done notching. For now, we're going to need a few more notches for the little stubs that come off the frame rail to mount this, these couple of bars to. I'm just going to put it back to 0, get it out of the way. This clamp works pretty conveniently for using the angle grinder to clean up the notches. So we'll put it in, put it on here, snug it back up. Alright, all of our tubes are ready to go. I'm going to put away, I think we'll leave the notch around. We're going to need to notch some tubes, but I'm going to clean up the area, put any tools away that I'm not going to be using, and then we'll start welding. Alright, I'm all set up to weld. I decided I am going to TIG weld everything. I do have enough gas. I haven't done much TIG welding lately, so it's always good to get some experience. I got some magnets laid out so that the tubes aren't going to roll around. I got the ends cleaned up because when you're TIG welding, you want things to be as clean as possible. I sharpened up 3 bits of tungsten because I'm not very good at TIG welding and I'm bound to dip them or foul them up a bit. I got a champagne nozzle or just a big Pyrex nozzle with a gas lens. Nice, good coverage, makes up for a lack of skill in welding sometimes. And especially, I don't know, it just seems to help. You can never get enough gas coverage in welding. When you're welding steel or stainless with aluminum, you wouldn't want to use that. But got the Miller Dynasty that I have set up. Got it on DC, put it to 97 amps because that's a prime number and I'm weird like that. And I'll turn the CoolMate on. Oh, I need to hit that with an extension cord, but we'll get the CoolMate turned on. That's just the cooler for the torch. Probably not necessary with, you know, this little amount of welding, but it's always nice to use. Why not? Makes things a little more consistent. So I'm just going to throw like 3 tack welds on each junction, do the pair of them, and then I will begin doing the final welding. I made this nice little third hand not too long ago out of a solid piece of steel here that's nice and heavy, acts as a weight, and then I welded on these 2 brass legs, and this one I just drilled and tapped that so that I can do different configurations if I want. But basically what this will do is it'll form a ground from the table, which is grounded from the welder, to the tube so that the tube itself doesn't ground through the table and stick to it. I don't know if you've done much TIG welding, but it's especially important like if you're doing like a stainless steel exhaust you want to keep nice. This keeps it from arcing to the table. Completely not necessary on something like this, but good habit to get into. I made it, so I might as well use it. So let me plug in the CoolMate here, and then I'll start doing some tacks. Alright, so now we should be able to turn the CoolMate on. There it is. Get my helmet on, turned on. Put my torch wear gloves on here. Grab a new piece of ER70S2 welding wire, and we will roast a tack in there. The other thing I need to do real quick is make sure that the little stub on the end is equal so that we get this thing centered. Good thing I remembered to do that. Let's see here. That's 1 inch. That's 1 inch, so it is currently centered. So we will put a tack on her. And one more tack before we go to the other side. And we will tack this side now, making sure that everything is nice and tight. And now I will flip it over and we will tack the back side. Shouldn't need these magnets anymore for this tube. Try to be gentle here. Flip it over. We'll get the third hand back set up on there. And we'll get another tack. Another tack in this side. And then this assembly will be ready for final welding. Alright. Get out there. Magnet. Alright. I'll push this back, get these magnets out of the way, get this one, come up here, and we will get this guy tight and centered. So it needs to come that way just a bit. Should be 1 inch on each end. Let's go back just a little bit. That is good. We'll put our third hand on here. Make sure that joint is tight. And now we will tack it. Make sure it's tight. It's time to lay some beads. See what happens. Down. Show you it here. Not too shabby. It'll work. I'll show you what I just did there. Adequate. Certainly not a robot when it comes to this stuff. But I also don't TIG weld much anymore. It's certainly been a while. Yeah. Not too bad. I'll show you that weld. Adequate. Show you this weld. Not too bad. And here they are. Finished TIG welding them. Turned out alright. Had a few spots I wasn't too proud of, but you can see the welds aren't that bad. Not too bad. And what's left? I'm going to make plates that go the whole distance with a long row of dimples in them. And then we need to weld up some base plates to the frame rail underneath the vehicle. Gonna do 3 of them. 1, 2, 3. Just tubes coming off. So I'll have to cut the base plates, weld those to the frame rails. Then we will get these things on some jack stands and whatever way we can, get them square and level and ready to go. And then we will make the 3 stubs for each one of the side steps, and then we will tack weld everything together, and then I'll break the tack welds off the frame rails, finish weld those stubs, and then by then we'll have the plate on there, and then I will paint everything so I can get all nooks and crannies. Then we will finish weld them to the chassis and spray paint that last little bit. So everything's good to go. I'm going to take a DA sander and clean up the tubes, and I'm going to start making some plates.